Welcome to this explainer. Today, we're diving into a seriously fascinating chapter in human history called A Story of Numbers. I am absolutely pumped to guide you through this material. We're not just looking at dry, boring math facts here. No, we're talking about the ultimate, world-changing software update for humanity. I mean, we literally use numbers every single day, right? But have you ever actually stopped to wonder, where did they even come from?
Well, let's just dive right into it. The chapter we're explaining today actually kicks off with a really cool little story about a girl named Rima. So one afternoon, she's reading an old book, and a piece of paper slips out. And on it are these incredibly strange wedge-like symbols. When she asks her dad about them, he drops this total bombshell. These symbols, they're actually numbers from ancient Mesopotamia, a civilization that flourished roughly 4,000 years ago in what's now Iraq. This totally sparks Rima's curiosity, and honestly, it sparks ours too. It leads us straight to a pretty fundamental question. Since when have humans actually been counting?
To answer that, I want you to try something with me. Just imagine, for a second, that you're a Stone Age farmer living 10,000 years ago, okay? You've got a herd of cows. Now, how on earth do you know if all your cows have safely returned from grazing? Or, how do you figure out if you've got fewer cows than the guy living next door? You have to remember, you don't have the words 1, 2, or 3. You definitely don't have a written Hindu-Arabic number system. So how do you solve this massive logistical headache?
Actually, the earliest mechanism of counting was pure physical genius, just in its raw simplicity. Early humans used stuff they had lying around in abundance. Things like sticks or pebbles. So for every single cow that walked out to graze, you'd set aside exactly one stick. Then, when the cows came back, you'd match one stick to one cow. This is what's called one-to-one correspondence. If you've got sticks left over at the end of the day, a cow is missing. And if you wanted to compare your herd with your neighbors, you'd literally just compare the physical size of your pebble piles. It totally worked. But as society grew, this method obviously hit some serious limits.
Right, because as humans started doing more complex things, trading goods, making ritual offerings, tracking the phases of the moon, piles of sticks just weren't cutting it anymore. We needed structure. And that brings us to a really core definition from the chapter, a number system. Basically, a number system is a standard sequence of objects, names, or written symbols, which we call numerals, that have a fixed set order to represent quantities. It was basically humanity's way of wrangling the chaos of the physical world and getting it down onto paper.
Now think about it. If you're inventing a number system from scratch, you need waypoints. You can't just invent a unique, brand new symbol for every single number up to 1,000,000. You would literally never remember them all. So instead, ancient civilizations came up with landmark numbers. These are basically easily recognizable reference points that act as anchors within a system. They help you group things together and make sense of massive quantities without, completely losing your mind.
Now, what's genuinely fascinating is how completely different cultures chose their specific landmarks. Here, we're looking at two ancient beta versions of number systems, if you will. On one side, we have those 4,000-year-old Mesopotamian symbols we talked about earlier, which eventually evolved into a base 60 system, also known as a sexagesimal system. And on the other side, we see Egyptian numeral hieroglyphs, which used entirely different symbols for ones, tens, and hundreds.
That Egyptian method? That's what we call a base 10 system, or a decimal system, because it groups quantities by tens, which makes total sense, right? I mean, look at our hands. We have 10 fingers. But it's crazy to learn that early humans actually aggressively experimented with all sorts of different bases. Like we said, the Mesopotamians use base 60, and the chapter even points out how indigenous folks on a Pacific island use a base 5 system, literally counting on different parts of their hands and arms.
But here is the absolute crucial point, and honestly, the fatal flaw in so many of these ancient systems. Doing actual math was an absolute nightmare. Just imagine trying to multiply Roman numerals, like multiplying MCCXXII by XIV. It's ridiculous. Because Roman numerals lack a clean positional rule for their landmark numbers, advanced arithmetic was incredibly difficult and super clunky. Believe it or not, it actively held back scientific progress for centuries.
Humanity desperately needed a better tool, and thankfully we got it. We got the ultimate software update, the 10 simple digits, 0 through 9. The entire structure of the modern oral and written numbers that we rely on today originated and was developed in India, roughly 2,000 years ago. And it's no exaggeration to say it completely and utterly revolutionized how we process the world.
The roots of this system run incredibly deep. Ancient Indian texts like the Yajurveda Samhita were actually naming numbers based on powers of 10, using words like eka for 1, dasha for 10, shata for 100, all the way up to a trillion and beyond. The physical writing evolved alongside it too. The very first known instance of a written zero, which was actually noted back then as a dot, is found in the Bakshali manuscript from around the 3rd century CE. And by 499 CE, the brilliant mathematician Aryabhata was pulling off elaborate, highly scientific computations using this exact 10-symbol system.
Now, this incredible system didn't just stay localized. It rapidly exploded into a global phenomenon. Starting from India, this highly efficient system was transmitted to the Arab world by around 800 CE. It was really popularized by great scholars like the Persian mathematician Al-Khwarizmi, whose name, fun fact, actually gives us the modern word algorithm, and the philosopher Al-Kindi. From there, it traveled across to Europe and Africa around 1100 CE. The Italian mathematician Fibonacci was a huge champion of them in 1200 CE, but get this, Roman numerals were so stubbornly ingrained in Europe that it actually took until the European Renaissance in the 17th century for these numbers to be fully globally adopted.
As his knowledge traveled across the globe, its name kind of shifted based on who was teaching whom. European scholars started calling them Arabic numerals, simply because they learned them from the Arab world. However, Arab scholars themselves called them Hindu numerals, directly acknowledging their Indian origins. Today, as historical texts are being accurately updated all over the world, the most precise and common terms are Hindu numerals, Indian numerals, or the transitional phrase Hindu-Arabic numerals. And just to be super clear here, the word Hindu in this context refers purely to the geography and the people from where these numbers originated, not the religion.
And this right here brilliantly illustrates exactly why the world ended up adopting this system. In the chapter, we see Rima and her father using an abacus. This perfectly captures the absolute magic of place value. See, in the Indian system, a symbol has both an absolute value and a place value. A 7 sitting in the ones column is just 7, but you slide that exact same 7 over into the hundreds column, and boom, it's 700. This positional genius, combined with the groundbreaking concept of using 0 to hold empty columns, meant that adding numbers, which the chapter breaks down beautifully with the abacus, was no longer this dreadful chore. It became a highly efficient, super logical process.
The famous French mathematician Pierre-Simon Laplace summed it up so beautifully, and I really want to read this quote to you because it just hits the nail on the head. He said, "The ingenious method of expressing every possible number using a set of 10 symbols emerged in India. Its simplicity lies in the way it facilitated calculations and placed arithmetic foremost among useful inventions." It is so true. The idea seems so basic to us today that we honestly forget to appreciate just how profoundly important it was. Actually, let me prove Laplace's point to you right now. Take a look at this number, 3,605. I challenge you to imagine trying to accurately write, communicate, or do any sort of calculation with this specific quantity without using the digit 0 as a placeholder for the tens column. You can't. Without 0, the 3, the 6, and the 5 would just collapse right into each other. It would literally be mathematical chaos.
So the next time you jot down a quick phone number or check your bank balance or even just glance at a calendar, take a second to remember the incredible evolutionary journey of those 10 little symbols. They are quite literally an ancient piece of technology that single-handedly upgraded human civilization. Which leaves me with one final kind of provocative thought for you today. If humanity invented the entire concept of numbers purely to count cows and sticks, what invisible, world-changing tools are we going to invent next to map the future of our universe? Thank you so much for joining me on this explainer. Keep learning, keep wondering, and I will see you next time.